Alright, let's get started with today's lesson on 8.2 graphing rational functions. First, if you could make sure everybody has a copy of the notes for today, and right now press pause until everybody does have a copy of the notes. Okay, so once everybody does have a copy of the notes, we'll start by just talking about rational expressions and rational functions. Rational expressions, it's just a polynomial divided by a polynomial. Rational functions is the same thing, it's just a function equals polynomial over polynomial. So, let's get into today's stuff. The first slide of the day, it says sketch the graph of the function y equals 1 over x. So why don't you get your calculator out to find a table, and I'll do that here. I'll pull up my calculator. And so in y equals, type in 1 divided by x. And then to help us with the table, we're going to hit second graph. And so we have our table here. We can scroll up a little bit. So we graphed this the other day, if you remember. At -3, it's -1/3. At -2, it's -1/2. At -1, it's -1. And at 0, it's undefined. At 1, it's 1, 2, 1/2, 3, 1/3, and so on. So let's graph that over here. So we said 1, 1, 2, 1/2, 3, 1/3. Then if you recall, if we went 1/2, that would be 2. Went 1/3, it would be 3. And so on. So this is going to look something like so. Then same thing up here. Oops. Right, and then the negative as well. So it's -1, -1, -2, -1/2. -1, -3, -1/3, and so on. So it's going to look something like this as well. Alright, so this is our inverse function, 1 over x. And down here it asks, what are the domain restrictions? And so if you remember from earlier in the year, the domain restrictions are what can x not be in this equation. And so in this equation, x cannot be 0 because you cannot divide by 0. So for the domain restrictions, x cannot equal 0. Alright, so that's just kind of an introduction to domain restrictions. Let's look at the next one. And this is a little bit more complicated. It says, what are the domain restrictions of this polynomial over polynomial or rational expression? So x cannot be whatever makes the bottom part 0. So when you notice here, this is a quadratic equation. So let's factor it. Okay, so we know the first is going to be x and x. And then we want two numbers that multiply up to 12 but add to -7. And so that's going to be x minus 4 and x minus 3. And you can always check by foiling. This would be x squared minus 4x minus 3x and then plus 12, which would give you x squared minus 7x plus 12. Okay, so the domain restrictions of this are whatever makes this 0 and whatever makes this 0. And if you notice, I don't really care about the top right now, because the top, if that's 0, that's fine. We just cannot divide by 0. So what would make this 0? That would be x equals 4. And what would make this 0? That would be x equals 3. So the domain restrictions are x cannot equal 4 and x cannot equal 3. Okay, so let's move on to the next idea. Obviously, if you have questions here, pause it and go over questions together. Okay, so the next idea is talking about vertical asymptotes, and you should have this on your notes. And I just want to talk about this for just a second, just to make sure we understand what this says. It says if x minus a is a factor in the denominator, but not in the numerator, then x equals a is a vertical asymptote of the graph. So we're going to look at some examples of this, but just so you know, this is what constitutes a vertical asymptote in our graph. Okay, let's look at the horizontal asymptote definition. This is much more involved. So for a horizontal asymptote, it says you got a polynomial p over a polynomial q, and there's all these different rules, and once you get some practice with them, they'll make a little bit of sense. So the first rule is if the degree of the top is smaller than the degree of the bottom. So in other words, if the top, let's say x squared, and the bottom, q, happens to be x to the fourth or something. So that would be a case where the highest degree on the top would be smaller than the highest degree on the bottom. Then y equals 0 is an equation of a horizontal asymptote. So you would just have a horizontal line at the x-axis, or y equals 0. Okay, the next case is if the degree of the top is the same as the degree of the bottom. So that would be like if they were both x squared type equations. And it says an a or b are the leading coefficients of p. So let's just imagine this one is 3x squared, and this one is 4x squared. So in this case, a would be the 3. I'll do that in a different color. And b would be the 4. So the leading coefficients are the numbers in front of the biggest exponent, essentially. So since x squared is the largest exponent on x, b, or 4, would be the leading coefficient here. Likewise here, since x squared is the largest coefficient on x, then a, or 3, would be the leading coefficient here. So the line y equals a over b is an equation for the horizontal asymptote. So in this case, the horizontal asymptote would have an equation of y equals 3 over 4. There we go. Okay, so that's the rule if they're the same. Lastly, if the degree of the top is bigger than the degree of the bottom, so obviously if this were like an x to the third, and this were an x squared, there are no horizontal asymptotes. So you don't have to worry about horizontal asymptotes if the degree of the top one is bigger than the degree of the bottom one. Okay, and we'll get some practice with this in just a second here. Let's do it right now. So here, the degree of the top is smaller than the degree of the bottom. And if we look at the previous slide, here the degree of the top was smaller than the degree of the bottom. Then the y equals 0 is the equation of the horizontal asymptote. So, what's the horizontal asymptote of this? It would be y equals 0. Okay, so for the next one, the degree on the top is 5, and the degree on the bottom is 5, so the degrees are the same. So that means the equation for the horizontal asymptote is going to be 2 over 3. So the horizontal asymptote is going to be y equals 2/3. And so what that's going to look like on a graph, if we've got our little x and y axis here, we would have, we'll use green, we would have a horizontal line at y equals 2/3. For this one, we would have a horizontal line, we can do that in red, right at the x-axis. That would be the y equals 0. Okay, so for the last example, if we look at the previous slide, the degree on the top is bigger than the degree on the bottom. And if the degree on the top is bigger than the degree on the bottom, then there are no horizontal asymptotes. So for this one, we can just write no horizontal asymptotes. Oops. Okay. Eventually in pre-calc you'll talk about slant asymptotes, but for this class right now we're just going to talk about the horizontal asymptotes, and for this there are no horizontal asymptotes. Okay, so on to the last thing before we practice some of this, and this is holes. And so holes are if you have x minus b as a factor in both the numerator and denominator of your rational function, then there exists a hole in the graph at x equals b. So what I mean by this is we have an x minus 3 on top and an x minus 3 on bottom, and so there's going to be a hole at x equals 3. Okay, so let's get some practice. There's a problem on the next slide where you have to do a lot of this stuff dealing with the vertical asymptotes, horizontal asymptotes, holes, and so on. So let's look at this one. Vamos a practicar. If you're in Spanish, you obviously know what that means. Graph the rational function. Be sure to find any horizontal and vertical asymptotes and find any holes in the graph. In addition, state the domain. Okay, so we have y equals x squared plus 2x minus 8 on top, and then x squared minus 8x plus 12 on bottom. So if your inkling is to factor these, you're right, so let's factor them right now. On the top, we're going to have x minus 2 and x plus 4. Okay. And why don't you pause the video right now, try to factor the bottom one on your own, give people about 60 seconds, and then hit play again. Okay, so hopefully you've had a chance to factor this. This one we should get x minus 6, x minus 2. Okay, so the first thing I notice is we have an x minus 2 on top and an x minus 2 on bottom. So the hole is going to be at x equals 2. Alright, so we kind of essentially cancel those out, and that causes a hole in the graph. Okay, we also notice that the degree on the top is x squared, and the degree on the bottom is also x squared. And so the rule we learned about the horizontal asymptotes is that the leading coefficients of the x squared on top and x squared on bottom are going to give us the horizontal asymptote. So the leading coefficient here is 1, and the leading coefficient here is also 1. So our equation for horizontal asymptote is going to be y equals 1 over 1, or just y equals 1. Okay, on to the vertical asymptotes. If it's in the bottom, but not in the top, which is x minus 6, that's going to give us our vertical asymptote. So, that means that x equals 6 is going to be our vertical asymptote. And then our domain. Domain is basically all real numbers. It can be any number, except it cannot be dividing by 0. So we can't have x equaling 6 on our graph, and we can't have x equaling 2 on our graph, because that would make, if this were 2, that would make this 0, and we'd be dividing by 0. And if this were 6, that would make this 0, and then we'd be dividing by 0. That's a no-no. So our domain is all real numbers except 6 or 2. Alright, so I gave you a table here. Let's try graphing it. But I'm going to start by labeling some of these key points on this graph. So y equals 1 is going to be a horizontal asymptote. And so I'm going to go up here and choose my line, and we'll just kind of put a dotted line at y equals 1. And then our vertical asymptote is x equals 6, so we're going to go over 6. 1, 2, 3, 4, 5, 6. And then we're going to put a vertical line at x equals 6. Okay, so to graph this, and by all means feel free to pause it if you need a little more time, to graph this, the key points for x are going to be around 6. So why don't we choose, looks like we have 6 things to fill in. Why don't we choose, 3 below 6 and 3 above 6. So we'll do 5, 4, and 3, and then 7, 8, and 9 to help us get an idea of what's on this graph. So we'll choose our pen tool, and down here we'll do 3, 4, and 5, and then 7, 8, and 9. And if you notice, I didn't choose 6 because 6 is going to be undefined. That's the horizontal or the vertical asymptote, and so we wouldn't do that because that's going to make the bottom 0. So if we put 3 into this big mess, you know what? Why don't we make our lives a little easier? Let's plug it into the calculator and let the calculator graph it for us. So in y equals, we'll type in x squared plus 2x minus 8 divided by x squared minus 8x plus 12. Okay, hit enter, and then we'll hit second graph again to look at the table. Okay, so at 3 it's negative 2 1/3. At 4 it's negative 4. At 5 it's negative 9. So let's just start filling those values in. And then we'll go back to our calculator for 7, 8, and 9. So it's going to be 11, 6, and 4 1/3. Okay, so let's graph these 6 points, and then we'll get an idea what the graph looks like, and we kind of sketch it from there. So 3, negative 2 1/3, it's going to look something like that. 4, negative 4, it's right there. And 5, negative 9, is right there. Okay, so our graph is going to look something like this. And obviously you can get a few more points if you want to be a little bit more accurate. But we know it's going to get close to that one, but it's not going to cross it. It's an asymptote. And then this one, likewise, it's going to get close down here and not cross it. Okay, so 7's at 11. I think this is 10, so 11's going to be somewhere up here. 8 and 6. 1, 2, 3, 4, 5, 6. And 9 and 4 1/3. So our graph's going to look something like this. And then you're done. So, just that. So, you want to make sure you graph it fairly accurately. I'm not going to require, 50 points, but at least give a few points to get an idea of what the graph's going to look like. And then you have to also include your horizontal and vertical asymptotes. Now, there's one thing we did not do yet. We did not include the hole. So let's go back where x is 2, and let's check our calculator where exactly that hole is supposed to be. So when x is 2, oh, it's an error. So it looks like it's going to be somewhere between negative 2.3 and negative 1. The reason it's an error, remember, is because it's a hole. We can't divide by 2. So somewhere between negative 1 and negative 2, if we look at our graph, it's a little bit off. So that's okay. It's whatever. So grab your eraser, make a hole at 2. And so I'll come here and we'll just do a little open circle for the hole. And now our graph is done. So you need to make sure you put a hole there. The reason we put a hole is because the graph is undefined at this point, so we can't shade in that point, so that's why you have to put an open circle. Okay, so we're done with this problem. Why don't you move on to the next problem? Hit pause here for just a couple minutes, and then we'll go over and we'll see if we all got the same answer for this one. Okay, hopefully you've had a chance to do this one on your own. Let's double check. So when you factor the top, you should have gotten x plus 7, x plus 5. And then for the bottom, looks like we get x plus 5, x minus 2. Alright, so obviously the temptation, we see the x plus 5 and the x plus 5. Let's just go right ahead and say the whole is at x equals negative 5. Okay, the other one, the vertical asymptote, if it's x minus 2 on bottom, but that's not on top, which we don't see an x minus 2 on top, that means the vertical asymptote is going to be at x equals 2. And then the horizontal asymptote, remember we look at the coefficient of the highest degree, so this is x squared and this is x squared, so they're the same. The coefficient here is 1, the coefficient there is 1. So our horizontal asymptote is going to be y equals 1 over 1, or just 1. And then the domain, whatever x cannot be. So it's all reals that are not equal to, and whatever would make the bottom 0. So negative 5 would make that 0, and 2 would make that 0. Okay, so let's draw that in. We've got our dotted line. Horizontal asymptote is going to be at 1. Vertical asymptote is at 2. Then the hole is going to be at negative 5. We'll use our calculator to get an approximation of where that is. So let's type this stuff into our calculator to get our table filled in. And once again, we'll probably do 3 below 2 and 3 above 2. That's going to be kind of where the graph changes. So we'll go to our calculator. Y equals, and we already have this kind of typed in, but 12x plus 35 divided by x squared. Whoops, I forgot my parentheses. Plus 3x minus 10. Right. We'll go to the table. And at 2 there's an error. There should be. That is our vertical asymptote. And I bet if we go look at negative 5 there's also an error. Good. So that's where our hole is. That's exactly what we're looking for. So let's do 3 points below 2, negative 1, 0, and 1. Alright, so that's going to be negative 2, negative 3.5, negative 8. And then we'll do 3 points above 2, so 3, 4, and 5. And I'll look at my calculator. Looks like it's 10, 5.5, and 4. Okay, so let's graph these. So negative 1, negative 2, 0, negative 3.5, and 1, negative 8. And then I'm going to hold off on graphing this just a little bit here. So then 3, 10, 4, 5.5, and 5, 4. Okay, so this one we can kind of safely sketch in. It's going to get close to that asymptote line but not cross it. This one, remember there's a hole, so let's go back to our calculator and get a few more points so that we know where to put the hole. So down here, the hole is at -5, so let's just kind of graph in those points between -5 and -1 where we left off. So -4 is 0.5, -3 is 0.8, and -2 is -1.25. So -1.25, -0.8, -0.5, and then there's going to be a hole somewhere here. Let's look what's on the other side of the hole. It's -0.125, so it's not going to be quite below 0 yet. So there's going to be an open circle right at -5. Okay, so now we can graph this. Oopsie. And it's going to look something like that, obviously now with this mess here. Okay, so hopefully you guys got that. Good luck on the assignment. Your assignment is going to be on page 46, and it's these problems. So why don't you get this copied down? Obviously, I'll be back tomorrow if you have any questions on the assignment. Have a great day.